Hello everyone. Today I am Tiara Ariska Devi. I will present the matter for Chapter 5, Ferrous Metals and Alloys, Production, General Purpose, and Application. Next, introduction. Ferrous metals are those that contain iron, Fe, as their major element. They are the most commonly used materials in engineering and manufacturing because they are strong, versatile, economical, and easily produced. Used in almost every industry, automotive, construction, machinery, appliance. The main group of ferrous metals are carbon steel, alloy steel, stainless steel, tool, and die steel. After focus on how these metals are produced, processed, and applied in engineering. Next, 5.2 Production of iron and steel. The production of ferrous metals begins with extracting iron from ores and driving into steel. Raw materials, their essential materials are required iron or the main source of iron. Coke, a carbon-based material made from coal, acts as both good coal and reducing agent. While limestone breaks with impurities to form slag, which can be removed easily. These materials are layered and charged into a blast furnace for smelting. Next, iron making. The blast furnace is a tall, vertical structure wherein ore, coke, and limestone are heated about 2000 Celsius. Hot air is blown from the bottom burning coke to produce carbon monoxide, which reduces iron oxide to metallic iron. The output is molten pig iron, contains 4% carbon and impurities. Slag, a byproduct made of silicates and oxides. The gas, mainly CO and carbon dioxide, are released and often used to heat the furnace. The process marks the first step of producing iron from ore. Next, steel making. Pig iron from the blast furnace is too brittle and contains the most carbon. Steel making removes the excess carbon and impurities to produce steel. Two main modern methods. One, basic oxygen furnace, BOF. Oxygen is blown through molten pig iron, oxidizing SEN into gas and slag. Two, electric arc furnace, EAF. Use electric arcs to melt scrap steel or pig iron, mainly used for recycling steel with controlled combustion and desired mechanical properties. Next, casting of ingots. In the ingot casting process, molten steel is poured into large molds and allowed to solidify. The solidified blocks ingots are later reheated and rolled into plates, bars, or rods. Problems uneven cooling may cause defects like segregation and internal cracks. So once common iron casting is no longer replaced by continuous casting. Next, continuous casting. Continuous casting is a modern process where molten steel is poured continuously into an open mold. As it solidifies, the steel is drawn downward and cut to this length advance, produce uniform structure and better quality steel, reduce waste units in use, and almost all steel today is produced by continuous casting. Next, carbon and alloy steel. Steel are categorized mainly by their carbon content and alloy composition. Effects of various elements in steel. As element affect steel properties. C. Carbon increase hardness and strength but decrease ductility. Manganese improves strength and wear resistance. Silicon improves elastic limit and oxidation resistance. Chromium in place hardness, strength, and corrosion resistant. Nickel improved stocks and impact resistant, and hence high temperature strengths. Next, residual elements in steel. Residual elements like copper, tin, RSN, arsenic, RIs, and antimony RSD remain from research scrap. This can cause embrittlement loss of ductility if their amounts are not controlled. Next, dashing using for steel, the IC or side for the system used to identify steel birds. First 2 digits owing elements, last 2 digits carbon content. Example IC 1040 means plain carbon steel with 0.40% Celsius. Next, carbon steel divided by carbon contents. Low carbon, soft ductile used for circuits and automobile bodies. 2. Medium carbon, high strength used for gears, axle, and machining parts. 3. High carbon, very hard used for springs, cutting tools, and high string wires. Next, alloy steel contain elements used as CR, NEMOV, V, or T to improve performance, provide better mechanical strength stocks, and heat resistant, widely used in automotive parts, tools, and structural components. Next, high string low alloy steel or HSLE contains small amounts of alloying elements. Would exhibit very high strings, lightweight, high string, good weldability, and corrosion resistant. Commonly used in pipelines, brakes, and facial frames. Next, ultra high string steel have tensile strengths above 1,800 MPa or 200 KSI, a safe drop advanced heat treatment and high oil content, application aircraft components, military vehicles, and performance parts. Next, stainless steel content at least 10.5% chromium, CR forming a protective oxide layer. This reference has 9 types: austenitic 300 series, non-magnetic, excellent corrosion resistant, E8 kitchenware, medical tools, and to ferrit for 400 series, magnetic, lower cost, moderate corrosion resistant, maintains very hard and strong, used for maps and surgical instrument, precision hardening, BH, combination strength and corrosion resistant for aerospace application. And 5. 7 tools and die styles are used to making cutting tools, molds, plans, and dies that shape order mass and use video. Table 5, 6, and table 5, 7. Next, high speed steel designated for cutting operation at high speed, maintains hardness up to 600 Celsius, alloy with tungsten free, molybdenum, chromium share, vanadium free, and cobalt seal. Common use drives, milling upper steps, and the lateral tools. Next, die steels used in forming process such as forging, extrusion, and stamps. Types categories: cold work steel, A, D, series for low temperature burning hot working day still has series for high temperature day application or resist high heat and pressure. Also, shock resisting steel has series absorb rapid impact fluids and convection. Ferrous metals are the backbone of modern industry. Innovation like HSRE, stainless and HSS still have improved strength, durability, and corrosion-resistant features. Quick corrosion and energy-sensitive production, but continuous material engineering keeps enhancing their performance. Next, reference Kapakjian S. Kapakjian S. 2010 Manufacturing Engineering and Technology 6th edition Russian Education Quiz. And thank you for watching. See you next video.